I'm here from Superconductive. We are the main developers behind Great Expectations, the open source project. Quick show of hands. Who here has previously heard of Great Expectations? Okay. Yeah, that's actually more than I would have thought. That's great. That is wonderful. A little bit about me. So I'm a data scientist, data engineer. I've been hands-on keyboards, munging messy data sets for a long time. When I say scientist/engineer, I start off much more on the statistics side, much more in the figure out what the data does side, rather than in the orchestrate the pipelines and make it work repeatably side. I mean, I do both of those things, but for me, I love human scale data. I love understanding the stories in data, and to the point of the keynote this morning, I really like understanding how data can be used ethically to make the world better. I'll also call out, it is weird to me, but this is the first time I've been back in New York since I was a kid. I grew up in Washington, D.C. and came up here a lot, and then somehow just did not make that a habit as an adult. So it's good to have an excuse to come back. Today, I'm going to talk about three things, kind of broad outline. The first is a thing that we do in the data community that I think is absolutely crazy. And I'm hoping to persuade you, or at least get you thinking that perhaps you're doing the same thing and perhaps it is crazy for you as well. After that, I'm going to talk about pipeline debt, so technical debt in all the data pipelines we build. And when I talk about data pipelines, I don't mean exclusively ETL or kind of SQL query type stuff. I'm thinking about data as it flows from the top of an organization all the way down through the bottom. So machine learning, dashboards, ETL, of course, data transformations in the middle of data warehouses. All of that I think of as various species of data pipelines. And then last, like I said, I'm here representing Great Expectations as an open source project. And like all open source projects, we are hungry for feedback and hungry for good input and contributions. And I have a few specific things that I'd love to ask the community for help on. So that's where we're going today. Chapter 1, a thing we do that is absolutely crazy. All right, so imagine that you are not a data engineer. Imagine that you're a software engineer, and the thing you do is you build microservices and APIs. And one day, you build a lovely new API, and as you're about to roll it out, you get together all the people who are going to be consuming from your API, and you say, okay, I've got this wonderful new API, and I would love for you all to use it. But by the way, there's no documentation, so you're going to have to figure that out for yourself. And on top of that, it seemed, I don't know, hard, so I didn't test it at all. But it's a great API. Please go ahead. And by the way, one last thing, it's not stable. The API, I'm pretty sure it's going to change at some point in the future. But I can't tell you when, I can't tell you how, and I might not even know when it changes. But it's an awesome API. Please go ahead. Please use it. So if you were a software engineer and this was your work product, I think the consumers of your work product would come to you and say, you are absolutely crazy. This API that you've developed is a prototype at best. And I, as an engineer, would be absolutely crazy to try and build something stable on top of this untested, undocumented, unstable thing that you've got. Right? I mean, that's the state of the art in the software world. But in the data world, if we flip it and we say, hey, I have this lovely table in my data warehouse. It's not documented, it's not tested, and it might change in the future. In fact, it probably will change in the future. Somehow we have all come to think of that as a normal state of affairs. So quick show of hands here. Who has run a query on some kind of important table or log file in the last month? Okay, most of us. How many of those tables, or the thing you were pointing at, how many of those were fully documented with documents that were up to date? Ooh, I count 3 hands. Oh, no, 0. Okay, no, that's a 0. Okay, 2 hands. Back down to 2. Okay, okay, so documentation does exist, but I'm going to assert that it is scarce. How about testing? So those important tables you were pointing at, did they have tests on them? Okay, we need to talk afterwards, because you're doing something cool. Let me flip around on the stable question. Who here has a story at the organization that they currently work for about that time that the dashboard broke? Who has a story like that? Okay, I'm actually seeing a little bit of timidness here. So this is the thing, right? Like, we're a little bit afraid to put up our hands there because, like, ooh, the dashboard broke, it's sort of kind of my fault. But it's also, like, the fact that we're working in a system that doesn't have the affordances to do the things that that it takes to keep our systems from breaking. So I put it to you that, like, we're kind of the frogs boiling in the pot. We've built out these complex, powerful, like, really interesting data systems. But in a lot of ways, the complexity of those systems and the coolness of those systems has run ahead of our tooling. And we've wound up in a place where we're maintaining these data systems that are just really hard to stay on top of. And there's a lot of pain there. So, point one, chapter one, trying to maintain a data system that is untested, undocumented, and unstable is absolutely crazy. And I believe that 2 years from now, 5 years from now, we will all look back on this period and say, wow, I'm so glad we got out of the dark ages, because like life is so much better when we don't have all these fire drills and confusion and fear around our data systems. All right. Now, I wouldn't have come all the way to New York for the first time in my adult life if I didn't have at least part of a solution to this. First step on this is I think we need to name the monster if we're going to slay it. And the name that I want to give to this monster is pipeline debt. I think we need to just be upfront about the fact that there is a lot of technical debt in our data pipelines. And I don't think that that's really, I think there's more that we can do as a community individually. But honestly, I think this mostly comes down to process and tooling. And there's some important parts of the data tooling ecosystem that have just been missing. And the one, of course, that I'm most interested in as a core contributor is this library called Great Expectations, which is intended to make it easy to test and document your data pipelines. And again, data pipelines is data of all kinds, machine learning models, ETL, data warehousing, all of the above. So let me take the next few minutes and describe to you how Great Expectations works, how we think about it, and kind of where it is in its life cycle as an open source project. So we call it Great Expectations because the core abstraction is an expectation. It's an assertion about data. And buried here is one really important kind of subpoint. In most software engineering, you test when things change, and the thing that changes most often is the code. In the data world, your code changes, your pipelines change now and then, but actually the thing that changes much more frequently is the data. I heard a really good, I need to go back and look up the talk. There's a really good line that says, in the data world, most breakages are caused by other people, whereas in the software world, most breakages are caused by yourself. So, assertions about data, expectations. We have things like, expect a column to exist. I won't do a show of hands, but when I've asked people about this, like how many pipelines have broken because a column was renamed, like stupid, simple thing. And yet, like, that probably has shut down a lot of people's data pipelines, and it took many hours to fix. Well, not to fix, to find and then fix. Expect the table row count to be in some range. We've got a bunch of things around the content of the data. So values should be unique. Values should be not null. And let me pause. We've got some nice affordances and Great Expectations that allow you to say things like, well, expect them to be mostly not null. Expect 95% of the values to not be null. Because it turns out that in data problems, often getting to total perfection right now just isn't realistic. But being able to say, hey, as long as it's 95% clean, that's good, and I'll figure out what to do with the other 5% later. Regexes, string time formats, right? All of our favorite problems in the data world. On top of this, we have a bunch of aggregate expectations. So things like, hey, the column mean. So like not individual rows, but like as an aggregate, what should the mean be? What should that be in some moving partition or window? And then this last one is a little bit obscure, but expect the column KL divergence to be between. This is a way of saying, I've got a reference histogram, so I know like the shape of the data last week, and I want the shape of the data to continue to be the same this week. So this is just a sample. The open source library has not quite 50 of these expectations, and they're a rogues gallery of all of the like weird stuff that breaks in data pipelines. They span everything from table and column formatting all the way down through contents, and then bordering into things that are more statistical anomaly detection type things. And they all fit into this really nice abstraction of an expectation. So just kind of diving in with where the project is overall, we have those expectation types. Actually, I should say, it's extensible too. And what we're finding is most people who are using Great Expectations, they start with our library, because that covers a lot of the common cases, and then they extend it out to cover the things that are meaningful in their ecosystem. And we've made that, there's more we can do to make that really easy, but we've made it easy enough that it's useful now. So we've got this concept of expectations. We also have this concept of data sources, and this is basically, think of it as like compilation targets for expectations. So initially we shipped with pandas, so you could run expectations against pandas data frames. The community almost immediately came back and said, hey, we really want to be able to do this in SQL. So we built Great Expectations out into SQL Alchemy, which means that basically anything that SQL Alchemy can point to, you can run expectations against without having to do anything special. So Postgres, MySQL, Hive, SQL Server, right? More recently, we had a community contribution where they built out Spark integration. So Spark data frames also have Great Expectations attached. And then just this week, I don't know if the folks from CityBlock are in the room. Okay, hey, nice to meet you. So the CityBlock team has just put in a PR that also extends Great Expectations to Google Cloud Store and BigQuery. So we're moving forward. Cool stuff there. Now, let me pause really quickly and say, when we first shipped Great Expectations, this was purely a side project. Nobody was working on it full time. And we had these two concepts, so expectations and data sources. It's a good start, but if you dig into it, you start to notice things like, hey, how do I store my expectations? And how do I schedule them? When something breaks or when an expectation returns a failure, what do I do with that? Like, all of those things would seem to be important parts of building out a data validation stack. And our mode at the time was, kind of the complete the owl mode. Like, well, we'll give you the circles, and you're halfway there to the owl, right? You can build this out yourself. As we've talked to teams that have implemented Great Expectations, what we've discovered is most teams that have built out kind of a full data validation layer were spending at least a month to get to the point where they had something that worked reasonably well. And then there was a lot that was being left on the table, just like a lot of other things they would have liked to build out. So I'm happy to announce that as of the beginning of this summer, we've been working pretty full-time on Great Expectations. Like, this is a commit history. As we all know, the number of commits in a repo is a really good indicator of progress in that repository. But like in this case, it's a decent metric. So for the last few months, we've been focused on really making Great Expectations a batteries included experience. And I'm excited now to, for the first time in public, show you some of the things that we have added to Great Expectations. So from an architecture diagram perspective, we have a bunch of new words that all go in their own boxes. I'm going to show you generally what these things do, because I don't think the words on their own will mean much. So first, we've set up a command line tool that makes it really easy to initialize Great Expectations. It's mildly opinionated about how it fits into version control, how it stores everything, how it retrieves expectations. It has nice integrations where you can connect to a bunch of different data sources, and that's pretty slick. And then, as you see here, it also allows you to profile data sources. So go through, inspect them, figure out what they look like, actually build some expectations automatically, and then convert those expectations to documentation as well. So more to get into here, but there's some cool stuff. And we've worked pretty hard. We're not done, but we've worked pretty hard to make this slick so that it does not take a ton of work to finish drawing the owl. Once you're set up there, we have the system set up so that it will roll out a bunch of config files. And I'm not showing you the whole config file here because they get kind of medium large. But our goal is to make it so that all of the important components of Great Expectations are pluggable. So for example, this is the line that you need to uncomment to activate Slack webhooks. So if you want to get Slack notifications after you run validation on your expectations, great, this is what you do, right? You get the webhook URL, you uncomment the line and paste it in. So it's slightly reminiscent of Django or a framework like that. We're trying not to be too deeply opinionated, and you can always disconnect the underlying layer if you want. But we're also finding that lots of people want that kind of batteries included experience. This is a kind of short animation of you ran your data validation, you clicked on a Slack notification, something was broken, and now you're clicking through to the static website that hosts all of your data documentation. If you look really closely, you'll notice some things that are not beautiful about this. But in general, the idea that you can have a static website that shows you exactly what's going on in your data, that's new, it's cool, and it's the kind of thing that would take a long time to build on your own. So we're making that part of the open source project, and it should just work out of the box. So the thing that we are working towards right now, and I keep hedging, I keep saying it should work, we're close to, we're almost there. What we want to do is we want to get to the point where any data team can set up their testing infrastructure in a day or less, rather than having to build out that whole application stack for themselves over the course of months or longer. We're not quite there. And I'll say more on this in the end. We are at what I would call a minimum viable product, in the sense that it works but has lots of rough edges, and we're actively working towards making that minimum lovable product that just really, really works. Before we go there, though, let me talk about one thing we're doing that I think is worth mentioning in particular, and that is this principle that your docs are your tests and your tests are your docs. So Great Expectations, because we're using this declarative language for expectations, it turns out that you can compile those expectations into human-readable documentation. And that's a really nice answer to a question that, or not a question, a problem that I've seen kind of discussed and floating around in the data engineering world quite a bit. A quick show of hands, who saw this article when it came out back in June? Okay, yeah, you probably don't need a data dictionary. So the case that the authors make here, which I think they are 99% correct on, is, well, I'll just lay it out. You're a data engineering team. You are consuming data from a bunch of different places, and you have a bunch of different data stakeholders around the organization who use the data that you produce. Maybe they're querying tables that you make, maybe they are looking at dashboards, maybe they're training machine learning models on top of what you do. All of those people who consume your data are going to be asking you for documentation, right? They're going to say, okay, what is this data? How does it work? Give me a data dictionary. Help me understand how it works. And the case that the authors make is that's really tempting, and these people are really going to want it, but it's actually probably more trouble than it's worth. And the reason it's more trouble than it's worth is because you have a version time version time version problem. And the version time version time version problem is different stakeholders are going to want somewhat different versions of the documentation. Engineers are going to want to know certain things about it. Non-engineering stakeholders inside your organization are going to want to know other things about it. People outside the organization, maybe they want to know everything, but they shouldn't be allowed to know everything. So you're going to end up with multiple stakeholders who each end up with a different version of the data docs. Okay, so that's kind of hard to maintain. But on top of that, the data is going to change over time, and the pipelines are also going to change over time. And in order to give people visibility into not just how the data works today, but how it used to work, and why those changes were made, you end up in this version time version problem, which is just prohibitive. It's way, way, way too much work to maintain that many versions of your data documentation. Unless you happen to have a technology that allows you to take your tests, which are being run continuously against your data, and automatically convert those into data documentation. So one of the things that we're really excited about with Great Expectations is this ability to take your tests and keep them in sync always with your data docs. The way we think of it is, as long as you're running your tests, which of course you're doing because you're not absolutely crazy, as long as you're doing that, your documentation will never go stale because your tests are your docs and your docs are your tests. So again, pretty animation that has some glitches if you look super closely, but this is what data docs look like in Great Expectations right now. We're pushing towards a good data view that will be flexible, pluggable, and allow you to do really good descriptions that always stay in sync with your tests. All right. I hope that sounds cool. I hope it's a new idea. I haven't seen anything quite like this out there, and we're really excited about it. The folks that we're working with to develop and deploy this are pushing us pretty hard to make it better fast. And again, we're eager for that kind of feedback. We've got the sense that we're onto something here. Okay, that said, warning, this is still quite new. there are still definitely rough edges. So what I'm trying to do is very definitely invite the community to participate, invite people to kind of get involved and help us out with this, but also just make sure that you don't get your fingers burned expecting a totally polished product before we're ready to promise that. Specifically, if you look at kind of the world of great expectations, the core expectation types and the core logic for most of the data sources is in pretty good shape. It's, green light. Data contexts, this notion of data assets, stores and validation operators, which are the things that allow you to kick off Slack messages and do all that magic, those are in pretty good shape. We've got a number of beta users out there. The core logic seems pretty stable. Of course, we're building under test and doing all those good things. But I would not be shocked to discover some complications there, especially in the onboarding process. I think as a core team, we're all agreed that we love what this looks like when it's built, but we're still figuring out how to tell the story and how to help people go from 0 to 10 and have it be a smooth process everywhere in between. So if you've got thoughts on our documentation, love to hear those. Last, this notion of renderers, so compiling to docs and profilers, those are the newest part of the project. I think there's a lot of interesting potential there. I think it is useful today, but just be warned that that's the least stable part of everything right now. Okay, so what I would like to ask specifically on this is if there is anyone who has been looking for a way to set up better data testing or better data documentation, like if this is on your roadmap, if it's a known pain point for you, we would love to work with you. And there are a bunch of different formats this could take. We're flexible. We're happy to help in any way that's helpful. But in particular, I think it would be nice to try and take this, this core promise we're trying to make of deploy in a day and do that with you. So work with us, pick a day. We will help you get set up. And in the meantime, we'll be looking really closely to figure out okay, what were the awkward parts? What were the things where our documentation just didn't quite cover it? What were the, where were we missing a more informative error message? And I'm pretty sure that if you're working with us, we'll be able to actually get you get you set up in a day. And in the process, we'll learn a lot about it and smooth the path for everybody who follows later. So if this is interesting, if this is something you'd like to do, I want to call out, I'm available, and we've got 3 other members of the Core Great Expectations team. Don't just raise your hands. You guys want to stand up? So Eugene's over here, Tal and Kyle. We'll be here right after the talk. We're also going to office hours, and then we've got a nice active Slack channel. If this or anything like it is interesting, we would love to work with you because we think that, we're actually pretty confident this is a very useful thing once you roll it out, and we want to do everything we can to help get people over that initial hurdle so we can solve this problem once and for all. Okay, recap. Trying to maintain a data system that is untested, undocumented, unstable is absolutely crazy, and I think 5 years from now we're going to look back and say, why did we ever do it that way? Thank goodness tooling finally caught up. The monster's name is pipeline debt, and once we've named it, then we can slay it. To defeat pipeline debt, you always need to know what to expect of your data, and in Great Expectations, we go straight after that. We want to get to the point, but we're not quite there yet, where anybody can set up data testing in a day, not a month. Your docs are your tests, and your tests are your docs. There are rough edges, and if you'd like to work with us, if this sounds useful in any way, shape, or form, please come talk to us, because we're really excited to roll this out. Thank you.
Yeah, so software engineering has a concept of mock objects and database seeding, whereas it looks like Great Expectations, essentially tests against some form of production data, maybe delayed a bit. But I don't know, do you see any space for mock data sets or whatever in a...
Yeah, so usually what I'm seeing for people who are working with Great Expectations is you want to test what's changing, right? And in the data world, your production data is the thing that's changing most frequently. So that's usually where people start because that's where most of the pain is. After that, we do see a lot of teams that'll do data snapshots, and they'll actually apply, using the same library, the same kind of tests to their code. But in general, you want to test the production data first, just because that's more of the pain is. Does that make sense? Does that generally answer the question?
Yeah, makes sense. Yeah, it just...
I mean, they're not mutually exclusive.
Yeah, right.
It's just sort of, what's your priority?
Yeah, no, that makes sense. It's easier to build out that infrastructure first. All right.
Yep.
Cool, thanks a lot.
Mm-hmm.
Just curious if there's any provisions or anything in the short future for dealing with privacy and trying to track, so for example, if there are sensitive data sets versus other data sets. I saw in some of the UI that you have, you're showing examples of data, whereas there could be some issues there. Just your thoughts on that?
Yeah, so that's a great question. To be honest, it comes up often enough that I know we're going to have to figure out how to deal with that, how to work with it. There's another thing that shows up in parallel a lot, which is you often have large data sets that have many columns or just like lots of complexity to them. And what we're seeing is a lot of teams say, hey, I don't want to deal with all 400 columns at once. I just want to like check the 20 that matter the most and zero in on that. So there's this notion of like importance flagging and also kind of privacy and protection flagging. Those seem to be parallel concepts, and yeah, we're actively exploring how to think about those, whether that should be a different flag or its own kind of expectation or something else in the system. And I will say, like, the system's flexible enough as it is that you can kind of hack around that pretty easily. You can kind of develop your own tooling there, but it's not a thing that we don't want to be opinionated about that until we're confident that the opinion we're expressing generalizes really well to most cases.
So this looks really interesting for documenting things for the kind of more technical parts of the organization. On the business side, one of the challenges that I face is, there can be 10 different flavors of revenue, for instance, and maybe the boss wants to look at one of those. Everybody wants documentation, and it is the classic problem, as you said, to keep that up to date is really hard. Is there any part of Great Expectations that helps you with that sort of higher level documentation, even if it's just sort of adding comments on top of what the sort of auto-generated statistical description is? And part B, if I can ask that, sometimes these things really make sense in a broader context where it's not just one object or one table, but how they interrelate. And is it possible to say, well, if things are going really well, I should be able to take this view, and this should be the relation between those two?
Yeah, so the answer on both of those is yes, we definitely, I would say today we enable that, but again, it's not fully batteries included. We think that a lot of the value for Great Expectations is to get into this like semantically rich, meaningful layer, and not just describe things in terms of schemas and formats, but to be able to actually bridge between roles. So when I talk about multiple stakeholders who all want different kinds of documentation, knowing like which revenue calculator was used to calculate that statistic, like that's exactly the kind of thing that we want to enable. Like I can't tell you how much of my life I've spent trying to figure out why denominators are different in two statistics, and that's exactly the kind of thing that like should be covered as more data systems come under better documentation. So if you want to talk more about that afterwards, and this goes for everybody, I'd love to engage in a deeper conversation.
How you doing? First and foremost, this looks really awesome. I had a question about under the hood. It looks like you're using like SQL Alchemy. What can you say a little bit more about what went into that selection process? My company's we built out a package similar to this, and we use like Python parser to kind of look at tokenization. Our use case was different. We're doing a lot of intake, so we want to be able to sift through different structure and be able to parse that way.
Yeah, the short version is, for us, we need to basically be able to, here I'll scroll back. We need to be able to compile these concepts down, and compile, it's Python, it's not really compilation, but convert these kind of semantically meaningful concepts into something that'll run against SQL. And of course, SQL isn't a single target. There are lots of different SQL dialects out there. We didn't want to get into the world of ourselves writing translators to each of those dialects. And so SQL Alchemy, and specifically the SQL Alchemy core, not the full ORM, I I think, unless somebody knows otherwise, unless there's some new hotness out there that I haven't heard about, it's the single best kind of close to universal translator that we have in the Python ecosystem. So, after looking at that and figuring that, yes, this will basically accomplish what we're trying to do, it was a pretty easy choice for us.